Hello, and welcome to our final lab for 380A, Ultra Mega Sagnac Fest 2K17. The purpose of this lab was to observe a Gouy phase shift using a Sagnac interferometer. A Gouy phase shift is a phase shift of 180 degrees which occurs when a converging light wave goes through its focus. The Sagnac interferometer was assembled using two mirrors, a lens, a beam splitter, and a light source, which in our setup was a laser diode. The components were placed as shown in the picture and were then aligned so the laser diode was seen as a perfect point source exiting the interferometer. We aligned an optical rail on the table so that it was perfectly parallel to the light exiting the interferometer, and a camera was then mounted on the rail on a translation stage to be used as a detective device. The camera was moved along the rail to observe the change in phase as two different beams produced by the interferometer came to focus in different locations.
Throughout the lab, we had to change the setup of our experiment several times due to issues that came up mainly with the light source and the alignment of the interferometer. So we first started with a green laser, which had to be replaced due to, well, initially the image that will get imaged onto the camera was so small that we couldn't get any data. And even after a magnifier, 60x magnifier, was placed in front of it, we would get so many fringes that nothing could be observed. So that later we switched to a laser diode, which is the current setup. But initially, since the laser diode was running a current that was right above threshold, the astigmatism was really high, and in particular, the lens right here was off-center, which increased even more the astigmatism, and we couldn't get any data as well. After tweaking the alignment and all and the mirrors and the lens and the laser diode, we were able to get the results that we will now show you.
As far as the theory goes of why we get what we get, it's all due to the fact that we have dual focus beams coming through our system, and they're expanding and converging at the same rate. When that happens, you have these beams focusing at different points out here in the focus, and so when the beams converge together, you have a central maximum intense spot. When the beams begin to essentially diverge or expand from each other, you end up with a dark central spot that can be seen, and as we move through the foci of the beams, you can observe these phase changes, which is essentially the Gouy phase shift anomaly that we want to see. So between the phases, as you're moving between each location, there's a pi/2 phase shift between each spot from dark to bright and bright to dark, which is a total pi shift of the laser beam itself.
This video shows our collected data on the detector of the two beams coming to focus. We see ellipsoidal fringes as expected from two spherical waves converging on each other. We see to begin that there is a dark center, and as the first beam begins to focus down, we see the bright focus spot. Then we see that beam begins to expand as a second beam comes down to its focus. We see the change from the dark center to a bright center to a dark center again, which shows the Gouy phase shift of a total 180 degrees.
The Gouy phase shift can be used to determine the quality of the beams being used, and a modern day application of the Sagnac would be in laser fiber gyros, and those are typically used in high performance space applications.